Okay. Hello, everyone. So first of all, I love the comments on the music. It's every time we start this show, I'm dancing, and I'm waiting for the next time that I'm going to get caught, doing my dance.
It gets me hyped up too.
Yeah, I am ready to go now for sure.
So on that note, here we go. Hey everyone, welcome to this special edition of Containers from the Couch. If you haven't seen us before, Brent Langston and myself, well, he's actually on this side. We do this show every Monday through Thursday, where we talk all things containers on AWS. So container services, it's not limited to just Kubernetes and ECS, EKS, ECS. We like to branch out as well. So today for the special edition, we're going to be doing live Q&A for our first ever Containers Conference. It's the first ever, right? I think I can say that.
I think it is, yeah.
Okay.
First ever Twitch one, yeah.
See, there you go. Okay. And so with us today, let me do some introductions. We have myself. I'm Adam Keller. I'm a developer advocate on the container service team. We also have Brent Langston, developer advocate on the container services team. Below me, we have Nathan Peck, who is also a developer advocate on the container services team. And in the corner,
I knew that was going to happen.
That was so good, and then I messed it up. And then we have Nate Tabor, senior product manager for EKS. So with that said, I'm going to pass it over to Brent. Let's do a recap of what we've seen today, what we've talked about, what's to come, and then let's get into it with some questions live.
Yeah, so, I think the conference has been going really well so far. I've been monitoring the chat, listening to questions and all that stuff. And if we just recap what we've looked at so far, I think it's been a very sort of well-packed conference. We started out with a keynote from Bob Wise, who is the head of EKS. That guy, if there's something that you want to happen in EKS and you can get his ear, then you're going to be doing well. You'll be able to, really influence that product. I think it's going to be awesome. He also is, of course, overseeing all of our open source contributions in the Kubernetes community and stuff like that. So, I mean, hearing what he has to say is kind of a rare opportunity, and I love being able to do that. We then went on and we started talking about CDK, and especially then CDK for Kubernetes. And there was some really cool chat around what about Terraform? What about Pulumi and stuff like that? So what do you guys think? What's going on with CDK? What should we really focus on and get out there?
Let's start with one of the Nathans.
By the way, did we introduce? Yeah, we introduced everyone, but I just want to point out that on Containers from the Couch, for the first time ever, we brought in two Nathans because we needed to bring in some big guns. So, we're definitely looking to them to be the experts here. So what do you guys think about, Nathan Peck, what do you think about CDK? What's it going to do for us?
Yeah, so I've been a long-time user of CDK back from when it was just in beta, playing around with the early build of it. And for me, it's been a major game changer. I remember in the past when I was working as a developer at a startup, I went through this gradual process of starting out using AWS just in the console. and it worked fairly well, but I always ran into issues where I couldn't reproduce things reliably. I'd find this working magic configuration that I went to go do it again, and it just didn't work. So I was like, I gotta solve this problem. And then I ran to a situation where I started adopting infrastructure as code with CloudFormation and other tools, but it just took a long time to write it. There was a lot of boilerplate I had to write over and over again. And so for me, when I looked at CDK, I remember my initial reaction was, man, this looks more complicated than the CloudFormation that I already know. But then when I spent a little more time with it, I dug into what it was actually doing. I realized that what I could accomplish with CDK was so much more concise than everything that I had written with Terraform or with CloudFormation directly. It gave me this idea to go straight from thought basically to the reality of a deployed application. I just think about, okay, I want this Lambda and I want it hooked up to this S3 bucket. And before, that would have been like this long process of, not only creating those resources, but also creating the relationships and the IAM roles and the security group and networking that allow that Lambda to talk to that resource. Well, now with CDK, I just say, I just want my CDK Lambda resource and I want to connect it to this bucket, and it just does all this automatically. So for me, I think CDK is amazing because it is this huge enabler of productivity. When I think about building a new project, oftentimes it starts on the whiteboard with some boxes. I draw a box for like, here's this application component, a little line goes over here to this queue, and then a line goes over to like maybe this other component of this S3 bucket or something. And that's really what CDK gives me, the actual components for those boxes.
You talking about that whiteboard thing really makes me think about, we're all the time trying to figure out how to help our customers stay focused on their application and their business logic and just, executing that. And I realized that CDK is like a huge enabler of that, because behind, that Lambda is all kinds of additional infrastructure that they don't want to have to think about. And behind running a container is a whole bunch of infrastructure that you don't want to necessarily have to think about. So just being able to, like you were saying, draw those relationships out and figure out what the workflow is for your business logic, that's what you're as a business owner or a principal engineer or something like that, that's what you're an expert at. You don't want to have to be an expert at all the other stuff below it. That stuff should just be utility, should just be boilerplate.
Yeah,
so
you usually know what you want to build, but you just want some tooling that will get out of your way now and let you build that as fast and easily as possible.
Exactly.
It makes me think of these higher level constructs. And this is where the CDK is so powerful, is having the ability to just say, for example, I want a load balanced Fargate service. So, Nathan Peck, I know you had a lot of feedback here, and this was something you contributed quite a bit to. But these higher level constructs take away the boilerplate, as you mentioned, but also it's the heavy lifting of trying to figure out how to sync all these components together, security groups, IAM roles. There's a lot of components that we have to consider when deploying a service in AWS. So it just makes it so much easier. That to me is where it was a game changer on the CDK. So I love that.
I think this is all true for Kubernetes as well.
I was about to say,
yeah, I'll turn it over to you.
Yeah, jump in there.
Yeah, no, I was going to jump in on Kubernetes here because I think that's really what's exciting. And I know a lot of people on the stream were just talking about CDKs for the first time. This is a pretty new project, right? Like, we announced this project about 2 months ago, I think, and put it out for a public preview. It's still an experimental alpha project. It's going to be moving to beta a little bit later this year. And we're really, actually, one of the things I'm most excited about is bringing this to the CNCF, the Cloud Native Computing Foundation, which is the organization that runs the Kubernetes project. They run the Envoy project. They run the Prometheus project. There's a whole list of really cool open source projects that they manage, and they have a forum for us to kind of bring newer projects like this for Kubernetes and the Kubernetes ecosystem. But all that aside, all those awesome things you guys were talking about, like, this is kind of where I think people that saw Alad's talk. So Alad is the engineer that's really our core engineer that's been both behind the CDK and the CDK for Kubernetes. And seeing what the CDK could do for AWS and AWS services and, AWS CloudFormation templates, and then looking at Kubernetes and saying, hey, it's actually kind of the same. Like there's a lot of similar problems here. I have a bunch of different API objects. I have to define them all together. I have to write all this YAML. I have to write a bunch of boilerplate code. If I get like a space wrong, my kubectl apply just fails, right? Like it's just like, oh, sorry, that manifest can't be applied to the API server. Like good luck next time. And you're looking at these big deployment manifests. You're like putting together stateful sets and deployments and services, and you have to like match up all the labels so that things like know to talk to each other within Kubernetes. And so you can like actually expose that, that pod out to the load balancer. And, all this stuff comes down to, how clean and crisp are you at defining those YAML definitions, and those files can get really large. So you're looking at the same thing, and you're looking at the same problem set. And what's cool about the CDK for Kubernetes is this was kind of taking the innovation that the team had done for AWS and originally was built to solve AWS problems, and saying, hey, there's a really good way, like we have the same problems across anybody that's using Kubernetes, not just AWS. So like people on Google, on Azure, on, you name your cloud provider, or you name your on-premises, or, like I think I said in the chat, like if you're running Kubernetes on a Raspberry Pi, like in your garage, like this is a problem that you probably have or that you might have. And so I think that's what's really exciting about the CDK for Kubernetes is we can take all this innovation from AWS and we can bring it out. And like, I think what's exciting for us is that there are projects like Pulumi out there. There are other people that are out there working to solve this problem. I'll just address that head on. Like we aren't the only people that can solve a problem at AWS. Like there are lots of people that come at problems differently with different viewpoints, with different ideas. And one of the places where we like to build and invest and build things in is ecosystems where lots of people are working. Like we love that idea that like, we don't want to be the one dominant tool ever in the world. Like we want to be a part of a larger community that's all aligned on solving the same problem. So we talk to those guys at Pulumi, like we learn from them. We hopefully they learn from us. I don't know if we've done anything super amazing and whiz bang quite yet, though we're working on a lot of really cool things like CDKs Plus. And that's the idea, is that like, there are choices out there. And so, it's hard to give prescriptive guidance to customers that said, should I use this or that? They're both awesome tools. We encourage you to check out all these different options. And, our commitment is to keep taking that innovation forward. And like, we have an open source roadmap, not just for container services, but also for the CDK for Kubernetes and for the CDK project in general. These are all open source projects. And we love your contributions. Like we want to hear from you. We want to make this really awesome. And, this is a place where, we can kind of bring some of that innovation goodness to a wider audience. And every time that I see the opportunity to do that, at least, and I know everyone else on the call, like if we see the opportunity to take some of that innovation goodness and spread it out and give it to more people, like we're never going to not do that. Like we're going to do that every chance that we get. And that's what really excites me about like the CDK stuff.
That's awesome. So we had a question in the chat that I think, since we're both here and we're all talking CDK, let me pop this in here. Delboy GG wants to know, can someone touch on how CDK and CDKs should be used together? What is the relationship there? And then I'm going to throw in a sort of follow-up to that. Charles, sorry, it's blue. It's hard for me to read. Wants to know, what's the relationship between CDKs and CDKs Plus? So kind of two prongs to that question.
So I'll start off the first one, then I'll hand it over to Nathan Peck, because I think he has some much more developed ideas on this. But CDKs is meant to define the Kubernetes applications within the cluster, and CDK is meant to define AWS resources. And when it comes to things like Amazon EKS, that's where things can kind of play together. And maybe Nathan, I don't know if you have some ideas on like how you might put these together to sort of build the infrastructure and deploy your application.
Yeah, so the way to think about it, there's levels of abstraction. So there is the baseline AWS resources that you have to provision on your AWS account in order for your EKS cluster to even function. And so there's this problem of like, how do I actually create a control plane, maybe even create multiple control planes if I have multiple teams? How do I create my VPC networking? Because I have like two different regions and they're connected by maybe this VPC peering relationship. How do I launch managed node groups for each of these clusters? So there's that level of problem to solve, and I think that's where you would probably use CDK to kick that off. The CDK8s, I always go back and forth on how I should pronounce that. I'll go with CDK8s. So that's like the next level up. The idea is, okay, I've got the cluster provision now, probably with CDK. How do I put things into the cluster? And so CDK8s is just focusing on some of the main top-level resource types, like Helm charts and pod manifests and stuff like that. CDK8s Plus is going a level beyond that. So the idea, one of the cool things about CDK is that you can create your own custom constructs. So you can start with a base construct and you can extend it and turn it into a new custom construct. So for example, let's say you want to launch a Redis inside of your Kubernetes cluster. Well, you could go all the way back to a baseline pod manifest and type out all the settings for launching a Redis inside of your Kubernetes cluster. Or you could start from a construct inside of CDK8s Plus, which is already a Redis pod definition. And so the idea is CDK8s Plus will become this library of different types of things you might want to deploy that are higher level patterns, and you can put them together in extendable ways and connect them to each other. And you don't have to necessarily think so much now about writing a Helm chart or writing a pod manifest, because you're just thinking, once again, in terms of those boxes. I'm thinking I have an application and I have a Redis and I connect the two together. So it's just different levels of abstraction that build up and up, higher and higher, to allow you to think about architecture rather than thinking about manual configuration.
That's agree. Awesome. And another good example there, to think about another good example there is like a lot of people commonly want to expose their containers as a web service, right? And in Kubernetes, let's say you have a stateful web service, right? You're going to actually have like 3 or 4 different objects that you want to link together. You want to link together the deployment, the stateful set, and also the Kubernetes service. And those are 3 different things you have to write as separate manifests or write them together in a single large YAML file. And like CDK8s Plus, you can actually have that as an abstraction. And so instead of writing 3 different Kubernetes objects, you just write on this abstraction of a web service object. And then at the next layer down, CDK generates all those different objects for you and deploys them, just like Nathan was describing. So it can really streamline and simplify development. And what's cool about this library is that it's fully transparent. So if you have different requirements for how these things need to be stitched together, you can fork that library out, you can modify it, and then use it internally.
And one of the things that I'm really excited about is how this is going to combine with the AWS Service Operator pattern that we're working on. And maybe Nathan Tabor, you might want to talk about that a little bit more.
Yeah, so we have this project. We have this project called we actually haven't brought this project out yet. So we're going to be bringing this out very soon here. There's an older version of this called the Service Operator. We're renaming it to the AWS Controllers for Kubernetes, or ACK. Some people call it ACK. Yeah,
I call it ACK.
I call it ACK. And what's really cool, acknowledge, yeah, like ACK. What's cool about this one is, and you're right, it is super cool that this is going to work together, because this is a set of custom resource definitions and controllers built around AWS APIs. So if today, like you made a good example of like running Redis within your cluster, right? And another common thing that people do is they run things like SQL databases, like MySQL as a pod, or they run message queues like within their clusters. And sometimes that's really good, and sometimes you just you really want to focus on actually running your app that you're writing. You don't want to have to run a bunch of extra infrastructure. And there's these awesome AWS managed services out there that actually provide those resources. Like we have services like SQS and SNS and RDS that provide all of these resources, but consuming those within a Kubernetes cluster, it can be really tricky, because you have to go out to CloudFormation and you have to provision, even if you're writing this all in CDK, even if you're writing it together, you have to provision it separately in CloudFormation. Then you have to go into Kubernetes. You have to grab those environment variables, say like your RDS database endpoint and your username and password, and you have to bring that manually into your Kubernetes cluster. And you have to do all this work to kind of hook these systems up. And so what ACK does is it lets you actually define those AWS service resources in the Kubernetes API language. And it has controllers that when you define, say you define a SQS message queue, we'll then call the AWS service APIs, create that message queue for you, and then expose the metadata that you need for your app to interact with that message queue back within the cluster so that your Kubernetes pods can interact with it directly without you having to go and figure that metadata out and push it back as environment variables into your app. And so obviously CDK for Kubernetes is going to support those custom resource definitions. So you'll be able to define the AWS services within your cluster using the CDK for Kubernetes alongside your native Kubernetes services. And so the idea here is that it kind of gets you out of the business of having to run a lot of these dependencies yourself within the Kubernetes cluster and gets you in the business of focusing on running your apps within the Kubernetes cluster and then taking advantage of those AWS managed services that are highly available, highly scalable. They're managed by whole teams of engineers that, just spend their lives, keeping SQS running or keeping RDS running. Like, I don't want to spend my life doing that. Like, I want to focus on writing my code, right? Like, any sane developer doesn't want to be responsible for message queues and databases. They just want to write their code and run their app. So it really lets you take advantage of the goodness of AWS while using Kubernetes.
So you bring up the developer and what they're, most interested in working on and stuff like that. But, there are other teams typically, especially in an enterprise, that are involved. And NetHole has a question here. And by the way, shout out for that name, because of course NetHole is going to have a security question. So yeah, how do you deal with teams that have security review, what developers do and what they expect, from that corresponding CloudFormation? That review, teams they don't want to have to learn CDK to review it. They want to be able to review CloudFormation. So what would be a typical workflow if you decide to implement CloudFormation in your service team and another team has to be there to be able to review it?
So there's a couple of different factors here. So first of all, these things aren't exclusive. CDK does generate CloudFormation. So there's no reason why a security team couldn't go ahead and review the CloudFormation that CDK generates prior to CDK deploying that CloudFormation. But one level beyond that, I would say more generally, what I would expect from my security team is I would expect my security team to become more and more advanced and take advantage of more automated tooling. So I would never want my security team to be just manually looking at CloudFormation to find issues, because that's error prone. They're going to miss things. They're going to have things that they miss or they're just not aware of. Ideally, they're going to be programmatically inspecting these things. And so more and more what I'm actually noticing people getting into is infrastructure as code testing. And you can actually write tests against your infrastructure as code and look programmatically for things like the security group is more open than it should be. It should not have SSH port access open to the world. Or it can find issues like, why does this EC2 instance even have a key pair associated with it? We don't want anybody to be able to SSH into that instance. Or it can say, I see that you're deploying an older version of X and you should be deploying the latest version. So it's actually even easier to write these type of infrastructure as code rules and tests in an automated fashion when you have a higher level language like CDK available to you. Because it has a lot of helper methods in there that allow you to essentially render the stack and write your expectations about what you expect the resources to be created with and how you expect the networking rules and security group rules and IAM permission shape to look like. And so you can write all these expectations now as tests in a real programming language rather than having to write a bunch of tests that actually look at the raw YAML. Yeah. So I would say it actually makes it even easier for your security team to do an even better security review if you're using CDK.
I think another cool thing would be the security team wouldn't have to necessarily review every single time someone calls a particular higher level construct. They could just review the construct, right? And then once they've agreed on all the security parameters that are sort of baked into the construct, then they don't necessarily have to re-review it every time that construct gets called. Yeah, I think that's another cool evolution.
That shared reuse is massive. What I've been seeing people do with CDK is they create a custom construct that's called something like my company service.
Mm-hmm.
And it's just an extension on the underlying constructs, which add a little bit of extra limits to it. Maybe it doesn't expose some of the parameters because they don't want you to be able to change them. And so it'll set like certain flags for security purposes, or forcefully add like let's say a twist lock sidecar or something like that to the service. And so that way developers, they just build off of that pre-built construct that was already vetted by security, and they have that ability.
Yeah, and
So,
go ahead. Go ahead. Okay, I just want to add that, if the security team or the DevOps team, the platform team, they own these higher level constructs that they've created for the company. Now when your development team needs to deploy an app, they just reuse this construct. You can make the construct very simple to use, and your construct itself could be complex. Like as you mentioned, Nathan, you can have you can enforce sidecars, you can enforce security group rules. That you have the power from a security perspective to control what your development teams are deploying and how they do it through reuse of a construct. So it's super powerful in that regard. And of course, one thing, if you do want to read CloudFormation, sorry, Brent, there is always the ability to synthesize your CDK into CloudFormation and run, as you alluded to earlier, Nathan, something like TaskCat or some sort of automated testing against your CloudFormation to ensure that you're meeting your expectations as well. So there's a few different ways to do it.
So one last thing on the CDK topic, because there's been more that we've seen this morning from the conference, but there's been a lot of questions in chat, so we need to address it. How does CDK handle state? There's a lot of questions around state management and stuff like that. So I know managing state with other platforms has been historically difficult, and especially if you have to share that state and stuff like that. So, how does that happen with CDK?
Yeah. So
can I talk a little bit? Oh, go for it, man.
Okay. Yeah. So CDK uses tooling that manages that state for you. So with CloudFormation, CloudFormation is keeping track of that state. With Kubernetes, obviously, you have that state inside of your etcd, and so CDK is functioning as the tooling which generates the infrastructure as code machine language, if you will, that goes down to these underlying providers, and then they manage the state within themselves.
So cool. I think a cool pattern that we see on the Kubernetes side is the GitOps pattern for managing state. So you definitely, you have within all these systems, right? You have your realized state and you have your declared state. And so for CloudFormation, CloudFormation is your declared state, and then that actual API that you're hitting against. Like in Kubernetes, there's a central API server in etcd, but in AWS, you have lots of different APIs, and they're all storing their state locally within them. And so you have your declared state in CloudFormation, you have your realized state, your actual state of the system in that API server. And then in Kubernetes, you have your actual realized state in the API server in etcd. And then what we see a lot of customers doing, and this works amazingly well with CDK for Kubernetes as well, is the GitOps pattern where your declared state is within a Git repo. And so the pattern that we see happening is I will use the CDK for Kubernetes, I'll generate that YAML, I'll do a Git commit to my repo, and now that's my new declared state. And then I have I have a Watcher CD pipeline, something like Flux or Argo, that's taking that declared state and implementing that on the cluster, and it's keeping my declared state and my actual state in sync. And so I think to kind of be really crisp on the point is that CDK is really designed to create that declared state for you in a well-formatted and well-templated manner. It's not actually meant to manage the state. And whether you're on AWS or on Kubernetes, we have other very developed systems that are going to actually manage the state and implement the state onto the system.
That's awesome. By the way, guys, we're getting huge. You guys are getting huge accolades in chat. They're loving all this, talking about CDK and CDKs and managing state and managing Kubernetes and all that stuff. So we do have to move on, but definitely, it's a good time to remind us. We have a regular show. It's relatively new. You may not have heard of it yet, but Containers from the Couch, every Monday through Thursday. typically 12 o'clock Pacific time to 1 o'clock Pacific time, so definitely join us. We do demos, we do discussions like this, so feel free to make it a lunch and learn, or whatever. Throw us questions. It'll be a good time. So next up, after talking about CDK, we took a look at Fargate Platform 1.4, and that was Massimo's talk. Massimo is one of our coworkers, so we definitely pay attention when he speaks. But what were some of the big call-outs there from Platform 1.4? And also, by the way, I think probably the most frequently asked question was, when will latest be pointing at 1.4? So let's talk a little bit about that real quick. How many of you guys have like manually or deliberately reconfigured your tasks to run on Platform 1.4 yet?
Yeah, I've done that. Yeah, so the big reason why we didn't update latest to point to 1.4 is because we did change from Docker to Containerd. And while this migration has gone really, really well, and we haven't had like a ton of complaints, we want to give people a chance to test out and make sure that everything is running perfectly smoothly on Containerd for their application, because that is a pretty big architectural change to get away from Docker and get into Containerd. But I'm pretty excited about the direction this is headed, and really what some of the stuff we're doing with Containerd and what it's enabling us to do with the container runtime interface, and what we're using. It allows us to implement some more of these plugins for storage, plugins for networking, that we couldn't necessarily do as easily with pure Docker.
Awesome. Yeah, same story here. What were you going to say, Adam?
Yeah, and I think the obvious, is just that EFS support. I know there's been a lot of ask around running stateful workloads in Fargate. So I think having and by the way, it's EC2 as well, with PV14, with the EFS support. But the fact that you can now run stateful workloads in EFS, that was huge.
Mm-hmm.
Yeah, totally. So that was a pretty awesome sort of revelation, and hopefully, the whole like latest not pointing to 1.4 thing is explained at this point, and we get it. It was a little bit of a safety concern that we wanted to make sure we didn't break the world or anything like that. So after that, we started talking about persistent storage on containers, and what I thought was funny about this is every time this topic comes up, I can remember like early on talking to customers, I would just sort of try and like harp on them, containers should be ephemeral. But then I started seeing that like no customer is asking me about, hard things about ephemeral containers. Those problems seem to be like relatively solved. And all customers want to talk about are stateful containers, because those problems aren't solved yet, or aren't solved very well yet. So that was something that like having some better integration with things that can help us have stateful containers is really nice. When you look at the Datadog survey, they release a container survey every, I think, few months. Maybe it's quarterly. And you look at the top 10 containers that are pulled, like number 1 typically is stateless, but like 2 through 9 tend to be stateful containers. So people definitely want to be able to run stateful containers. When it comes to running stateful containers on EKS or on EKS, what do you see people doing, and how do you decide, especially on EKS? There's always the choice of, do I use EBS or do I use EFS, or should I code my app to talk to S3? So like, there's a lot of choices. What do you pick?
You should always use EBS. No, I'm just kidding. It's really, it's a tough choice, man. I mean, it's so dependent on what you're doing, right? So like, if you're running something like MySQL, right? Like some stateful app that needs like file system, or not file system storage, but just like local disk storage, right? That's EBS, right? All the way. And if you're doing something that's file system based, then, you know, EFS. And then a lot of stuff that we're seeing lately, especially for machine learning. So machine learning on Kubernetes is huge for us, right? So we have a lot of customers using, you know, Kubernetes, things like Kubeflow, things like Spark, to run ML jobs on EKS, and we have actually done a lot of work with the Kubeflow team and a lot of optimizations on EKS to make it really awesome. And we actually see this newer file system from AWS called FSX. It's specifically FSX for Lustre that's becoming really popular for customers. And so these are 3 different file storage options for stateful workloads. They all do different things. The cool thing about Kubernetes is that recently Kubernetes has transitioned from what we call in-tree, where the code, kind of the glue code that connects the Kubernetes API with that underlying storage resource, has transitioned from being very static and tightly coupled to more of a provider decoupled model, where you actually run a driver on the cluster, and that driver handles workflow actions of the underlying storage resources, things like provisioning an instance of storage or reserving that instance as part of a stateful set, et cetera. And so those container storage interface drivers, or CSI drivers, are becoming the standard on Kubernetes. And we've published 3 CSI drivers so far. We have a CSI driver for EBS, obviously. EBS was also supported as the in-tree kind of older model. We also have published CSI drivers for the AWS Elastic file system, and also the FSX file system for Lustre. The FSX for Lustre, I just think is super cool because it actually is almost like an accelerator on top of S3. So it's backed by S3. It actually runs what's called a Lustre cluster in front of those S3 buckets, and it handles you know, sharding out that data and basically lets you interact with S3 just like it's a file system. So I think that one is actually super, super cool. There's some rumbling and some talk about potentially building a CSI driver for S3 directly as well. There's some conversations happening, and we've heard from some customers on our public roadmap that they'd really like to see a direct CSI driver so they can use S3 buckets as stateful resources within their clusters. But, you know, I would say that it really depends on what you're doing. And on the Kubernetes team, you know, we're committed to supporting customers for all those different types of workloads. And so that's why we have CSI drivers for all these different storage options on AWS. And what's really cool about Kubernetes is that at the end of the day, it's a stateful set, right? So you can define that stateful set, you can define that reservation of that storage resource in your Kubernetes API the same way. And you can consume those different types of resources in the same consistent way within your cluster and within your application. And that allows you to kind of optimize and figure out what makes the most sense for you guys. So if I went into all the trade-offs, it would probably take the rest of our session here, so I won't. But I think that's the high level, is that, you know, we have a lot of options, and we're continuing to innovate and kind of support customers for whatever makes the most sense for the apps that they're running.
Well, what I take away from what you told me is, yes, there are many tools that you can use to solve your storage problems, and it sounds like those teams are working on making those tools converge almost with each other. So any of those trade-offs that you might be like, you know, feeling like you're compromising, well, you know, that sounds like the teams are working on removing those compromises, and that's pretty cool.
And ultimately, it should be pretty easy to test too, because like you said, they're all stateful sets in Kubernetes. You could go from one to the other to the other. Anytime you're implementing state, you're going to want to test that pretty thoroughly, load test it. So why not test all 3? And you'll get a sense for which one works best for you.
Exactly, and it's like someone said a bit ago in the chat: if you don't want to learn new things, don't go into tech. You know, like things are always moving, always changing, and you know the constraints that you have today won't necessarily be the constraints that you have tomorrow. So
I was excited when they announced that 400% performance improvement for EFS, because after they announced that, I started seeing even more use cases where maybe before people would have chosen EBS, but now that there's a 400% performance boost on EFS, they're like, okay, let me try EFS, and it worked for them. So
that's huge.
You know, it's one of the things where you just try it, and then maybe you try it again a year later, and you're like, okay, this works now.
That's such a great example. Like this, you know, so I was an early adopter of EFS back when I was a customer of AWS. And I remember the use case with Jenkins, We were deploying it in containers. It just at the time didn't work for us. Fast forward to today, that use case is perfect for your Jenkins leader node to store state in EFS and run it all containers. I love now how we can run Jenkins completely serverless, completely Fargate, right? And your state is stored in EFS. So it's just cool to talk about the evolution. While a service may not work for you today, I guarantee you come back a year later, we've enhanced it, we've improved it, and there's a good chance it may work for you. So
by the way, Adam, what I just heard you say was, I love that we can run Jenkins. And I just want to like hammer on that just a little bit.
Well,
okay, never mind. I know how much you love Jenkins. It's okay.
Did it get cut off or something? Did I get misinterpreted here?
No, I'm taking you out of context.
Whoa. I'm big in the CI/CD world. I love it. I personally like to use something where I don't have to manage anything. That's my personal preference. So I always lean towards the code pipelines, the code builds. But not everybody's like that. Sometimes they like Jenkins, and I can't blame them for that. So let's run it as easy
I blame them for
as
that.
possible.
Okay, so after talking about persistent storage and everything, then we got into machine learning on EKS, and there's actually a lot of like that created a whole new flurry in the chat. There were people, like early on just saying like, why isn't Mike talking about Kubeflow? And then he started talking about Kubeflow. So what is kind of the current state of affairs on machine learning, and what are people doing with it on EKS, and like what are some of the problems that we're working on solving?
Yeah, so there's a lot going on, right? So I think that we're working on problems kind of at almost every layer of the stack, right? Like we were talking a minute ago about solving some problems on storage, right? So like building the CSI driver for using FSX, like that was a big project that we worked on in the last few years here, because customers need really hyper fast storage. If you're doing big training, you want to bring that in. We're also working, so it's everywhere from like up the stack with Kubeflow stuff, and we can talk a little bit about that. But a lot of our work has actually been focused on kind of lower level constructs and integrating Kubernetes with that AWS infrastructure that makes machine learning so powerful. Because machine learning on AWS it's a full stack endeavor, right? It is higher level constructs. It's things like Kubernetes or SageMaker, or and then libraries, and we even have like fully managed ML services, right? That kind of like wrap all that together, and you just like hit an API and you get a result. Things like Poly and Lex, right? These higher level services, and then it's all the way down to like the instance level. So one of the really cool things that we recently announced was support for Inferentia. And Inferentia is a new EC2 instance class that's focused on inference workloads. So in machine learning, you have typically two types of workloads. You have generally inference, and you have training. And so training is where you're building those models. You're feeding in a ton of data, and you're actually building that neural network. You're building that ML model. And then inference is where you're running that ML model, and you're actually like taking in new and novel data that you have training data is usually tagged. It's well understood. You might have a picture of a boat or a sound of a bird, and you're telling the computer, here's what a bird sounds like. This is a bird. This is the type of bird, and it's associating the sound with the label. And then when you're inferencing, you're taking in unlabeled data, right? So you're just listening to recordings of birds, and then you're expecting the neural network to come back and say, hey, that's a bird. I know what kind of bird that is, right? So those are two very different processes, and they require, you can run them on the same kind of general instance types, but it's not optimal. And so typically training instances have really, really powerful GPUs. They're very, we're talking about some of the largest EC2 instances, the most powerful EC2 instances that AWS makes and provides, things like the P3 DN 24X large, which is just like this beast of an instance with super powerful NVIDIA GPUs. And like it costs, I don't even know what it costs per hour. It's not cheap, I'll tell you that. And you usually only have to run that a bit to do your training job. But then when you're doing inference, you're scaling that out, right? You're taking that model you developed, and that model may have been very expensive to develop, and you're running that. And so Inferentia is a new, cost-optimized, highly efficient machine learning instance that's designed for these inference workloads. And so we've recently announced integration and support for Inferentia for these INF1 instances with EKS. And so that's really exciting for us because we've seen a lot of machine learning training on Kubernetes, and now we're enabling customers to do machine learning inference on Kubernetes. Higher up the stack, we worked really closely with the Kubeflow community last year. This is kind of silly, like it's not silly, but it seems silly to say that like documentation was a problem. Like that there really wasn't very good docs. Like people were like, hey, I want to run Kubeflow on AWS. It's not even possible. We're like, it's totally possible. It's just like not there. So it took us, we did a really big turn and actually contributed a whole host of docs and did a bunch of validation, did a bunch of benchmarking, and really, give people the tools now. If you go on Kubeflow today, you'll see a whole host of documentation on how to use Kubeflow in AWS, and that's super valuable for customers. There's stuff happening all across the stack there, and I think the high level is that for machine learning, we're looking to enable customers, everyone from companies that are doing autonomous vehicle research and like some of the companies you may have heard of out there in the world that are doing like AV research. I won't name names, but they're you know them, they're well known. All the way from companies like that down to developers that are looking to build kind of like their first machine learning app on AWS. We're looking to support customers across that spectrum and on AWS in general. So whether you're using Kubernetes or if you want to take a look at like our stuff for SageMaker, and we also have some of the ML team is working on things like Spark libraries. We recently announced a partnership with, not a partnership, but we collaborated with Facebook to do some work on Spark and other types of libraries. There's a project called PyTorch that we did a bunch of innovation, a bunch of work around. And so, the idea is that if you're coming to us with a big data, machine learning workload, that we're gonna work on the lower level hardware. We're gonna work on the software connectors, those drivers and the integration points. We're gonna work on the libraries and the frameworks. We're gonna work on the workflow engines, all the way that whole stack to give you a really great experience on AWS for machine learning and big data processing.
That's awesome. So we're about 10 minutes, maybe 13 minutes left in the show. So let's talk real quick about what's coming up next. Next up, we're going to be talking about, this is one of my favorite topics for the day. And in fact, because I've got to know this team a little bit, I am not shocked at all about the title of this, Happy Building with AWS Copilot. The team is super positive. They're fun to be around. So the fact that happy is the first word in their title is just awesome. But tell me, I know Adam, you and Nathan Peck have both worked quite a bit with Copilot now. So like, what should we expect to see?
Much happiness.
Yes.
Really, even from the time that I played with an early build, I think back in last December, already like using the early build of what became Copilot today, it really did make me happy because once again, I talked earlier about that journey I went through with infrastructure as code of like starting out just clicking around the console, creating things by hand, and then my desire to basically go from that whiteboard diagram to deploy infrastructure faster. Well, Copilot is another take on how you might be able to accomplish that. And the idea is it is designed to handle things at several different layers of the stack. So obviously, if you're deploying a container, you need some kind of infrastructure to deploy it on your AWS account. You need to have a cluster. It needs to be inside of a VPC. You need these kind of infrastructural related things in order to even put your container into the cloud. So Copilot, first of all, takes care of that. All I type is Copilot in it. And just Copilot in it and initialize the environment, and I'm done. Like I don't have to think about, what instance size and type because it's using Fargate. I don't have to think about, what availability zones I'm going to be deploying in, how many, because it goes ahead and sets up a high availability VPC networking for me out of the box. And even optimizes for cost. Sometimes if you don't know what you're doing, you could provision a lot of expensive NAT gateways or something like that. Copilot avoids that out of the box. So then the next level is I want to get my cloud, my application into the cloud there. So I start out with just a Docker file. Normally if I was a developer, I'd have to do it in there and type out this, Docker build command, Docker push command, create an Elastic Container Registry or Docker Hub up there in the cloud to actually push to. Well, Copilot, I just type a command in my current working directory where I have my code. It goes ahead and finds the Docker file for me. It builds it automatically and pushes it automatically. And I think that workflow is so much simpler than any other tool that I've worked with before, because a lot of the container orchestrator tools, they require that you do that build and push manually before you even start talking to the container orchestrator's API. And then from there, the next level that I really appreciate about Copilot is that it has easy commands built in for the next level, which is my container is actually up there and running in the cloud now. It was automatically put behind a load balancer. I have the URL. Something is going wrong. I'm seeing an error. What's going on? I can type Copilot logs, and I can start following logs, a live tail of logs from the task that I'm running. So they're really doing a fantastic job of working on the end-to-end experience, not only of the initial deployment, but also what comes next, the monitoring, the observability, the scaling.
And I just want to say the ability to actually use Copilot to deploy a CI/CD pipeline on your behalf. That's huge because let's be real, configuring CI/CD pipelines, it's challenging, and it's tricky. So this, and again, when we talk about frameworks like this, it's all about the opinionated nature, and Copilot is opinionated in giving you best practices, helping you to deploy using best practices in AWS with CI/CD, as you mentioned, cost savings as well as security. So it's all those things considered into one tool. It's Brett and I we did a live stream where we called it Unboxing Copilot, and we had never used it before. I mean, right. I played with it very early in beta, but that was brief. So we were brand new to it, and it was so easy. We deployed our existing services, and it was in a snap. So
yeah. And, we've had a couple of questions in the chat. One was from Enrique K-Chan. I'm interested in Copilot. And then another one was big picture question. Can you talk about the value proposition of Fargate versus other PaaS solutions? And I'm not ready to call Fargate a PaaS or even say that it's comparable, but I do think that if you have the right kind of tooling, the kind of tooling that can sort of bake opinion in for you and just walk you through the build out process and the management process and all the day two parts, then you can go to something super simple like commit and push my code, and then let it do its thing after that, and it'll make its way all the way up to running in the cloud. And I think Copilot is a really, really good start at making that kind of magic.
Yeah, so the deployment pipeline magic is already in there. It'll create a deployment pipeline for you automatically. The next piece of magic that's coming down the line on the roadmap is persistent storage. So that's the next thing that oftentimes you have a little application and you just want to talk to a SQL database. Well, Copilot will be able to provision that SQL database for you automatically, set up the networking rules and IAM rules and everything required for your application to be able to talk to that database. So it's really going to start serving more and more different types of applications for that simple first time you want to deploy your application. Copilot is going to be there for you.
Yeah, that's so cool. So after Copilot, the next thing that we're going to be talking about is we're going to do an extremely deep dive on Amazon ECS capacity providers. And I'm just setting up Adam because Adam is the presenter. So you don't want to miss that. You definitely want to stay tuned for the rest of the afternoon and see the talk on capacity providers and Copilot and configuring app mesh. And then there's been some questions about Docker desktop integration. And we end the day with security best practices around Amazon ECR, and then we'll have a live closing session with our chief evangelist, Jeff Barr. So we have a lot more in store for the rest of the conference, the rest of the day. You definitely want to stick around. Adam, what should we expect from capacity providers?
Well, by the way, I have to just say, I hate that I'm branded as the Jenkins guy now. So please, remove that. Okay, we're gonna actually go back to the recording and cut that section out. But anyways, I'm kidding. But so with capacity providers deep dive, we're actually going to talk about. We're really going to go into it. So we're going to talk about what capacity providers are for ECS. We're going to talk about the different strategies that you can implement, whether it's Fargate, little teaser here, mixing your tasks between Fargate and Fargate Spot. So you do a little cost savings in there. And also we're going to talk about cluster auto scaling, which is huge because this has been something that customers have talked about for a long time on ECS, customers managing EC2 instances, running EC2 backed ECS tasks, having to think about scaling both dimensions. I don't want to give away too much because I'm just going to do it all here. So.
Some of our ECS customers may be familiar with all the Lambda functions for auto-scaling cluster. There's been a lot of blog posts about here's my custom Lambda for scaling cluster. You're going to find out why you don't need that anymore.
Exactly. Yeah. So I love when, I think I said this on one of our earlier streams, but I love when I get to delete infrastructure.
Oh, yeah.
So, you can solve all kinds of problems, and I think AWS definitely has the broadest and deepest tool chest available to be able to solve problems. But anytime I get to like delete infrastructure because a service team has sort of consolidated all of those solutions into a feature, then that's one of my, a great day for me. I love deleting infrastructure. So,
yes.
Yeah. Okay, so we are almost done. We've kind of recapped everything so far. We've made fun of Adam quite a bit, so that was a good time. Are there any? Have you guys been following in the chat? Have there been any new questions? Oh man, they're even renaming you, Adam. Real
I know.
Adam Jenkins.
I've been branded. I can't believe this.
That's all right. They actually, people are extremely excited about Jenkins. Overall, it's definitely getting a lot of attention. So that's cool. Yeah. All right. So there was one last, I can't remember where it was. What can we talk about when it comes to blue-green deploys? That was the final sort of topic that I've seen, come up a few different times in the chat. Like for example, this one, Prime via Creator. Any plans to enable capacity providers with ECS blue-green deployments?
Roadmap.
Do we know? This is when, exactly. This is when I typically throw it to the roadmap, and I just want to, tell you we do have a public roadmap. Please check it out. This is the URL for it. So hit up the roadmap, and if there's not already an issue created, then definitely open one. I think that'll be that'll be the thing to do. So describe your issue if you can.
Definitely leave a comment on there because we reference those issues and comments all the time in internal meetings when we're talking about how we're going to build a feature. We'll be like, yeah, here's this comment from GitHub. Here's what this person said about what they needed. It's very helpful for us to make sure we're building the right thing for you.
Absolutely. All right. So with that, I think we're going to sign off. So I appreciate everyone. Definitely stay tuned. Next up is going to be AWS Copilot, and you definitely don't want to miss that. Thanks, everyone.
Awesome.